to do this. In your best note-taking ability, draw me a 6x6 grid. Leaving a little spot on the other side. In other words, do this. 1, 2, 3, 4, 5, 6 squares this way. And 1, 2, 3, 4, 5 squares that way. Nice grid right there. And what we're making the grid for is we're going to jot down all the possibilities you could get when you roll 2 die. Charlie, with me?
Yeah, that's just perfect.
Right. Perfect. Okay. So dice number 1. Obviously, you know that when you roll above this thing here, you can roll either a 1, a 2, a 3, a 4, a 5, or a 6, right? Dice number 2, you can do the same thing. You can get a 1, a 2, a 3, a 4, a 5, or a 6. Now, all of these numbers we write down are all the possibilities when you roll those dice, and you'll see it as it comes together here. Okay, you can roll a 1 on the first dice and a 1 on the second dice to give you a total of 2. A 2 on the first one and a 1 on the second one to give you a 3, a 3 and a 1. So it's going to establish a pattern that looks like this. Are you with me? If you rolled a 6 on one and a 1 on the other, you get 7. A 1 and a 2 gives you a 3. And so on, and so on, and so on, and so on. You'll be able to see all the patterns just falling together nicely. Give you a chance to write that down. And just looking at this lovely thing here, which number has the highest probability of showing up if you roll 2 die? What number comes up most often? Alex?
7.
Right. You have how many 7s are there? 1, 2, 3, 4, 5, 6. You have a 6 out of 36. Probability of rolling a 7, which is 1/6. 1 out of 6 times, you're going to get that. Now, why is rolling a 7 going to happen a lot more times than rolling a 12? Nate?
There's only one way to get that.
Right. There's only one combination to get a 12, and that's a 6 and a 6. Whereas with 7s, you can roll a 1 and a 6, a 2 and a 3, a 3 and a 4, a 4 and a 3, a 5. So that's why the probability of that happens more often. And the book's going to ask you some questions about this, so it's good to have this little table where you can look at it and see. Now that's not really what today is about, but it's close. What today is about is this. What happens when you want to get 2 things together? For example, if I asked you what would be the probability of rolling back-to-back 7s, a 7 and then another 7. And by the way we write this mathematically, you do it like this. The probability of a 7 and a 7. What would be that probability and how do we figure it out? Anybody? Anybody know what that probability would be? Of rolling 2 7s back-to-back. Probability of that would be, it is 1 and something. Great start. It is not 1/7. Holly?
1/12.
It is not, but you're getting closer here. When you want 2 events to happen, okay, with 2 events, you multiply the probabilities together. okay? In other words, the probability of each event happening, you multiply it by the probability of the other one. So the probability of rolling a 7 we already established was a 1/6. Probability of rolling a 7 again would be 1/6. The probability of both of those happening back to back would be 1 out of 36 times. Or the odds wouldn't be 1 out of 36, but the probability is 1 out of 36. Okay.
How did you get 1/6?
Oh, we did it already right here. How many 7s are there? 1, 2, 3, 4, 5, 6 7s out of 36 squares. Reduce it down to 1/6. 1 out of 6 times when you shake and roll 2 dice. For what game do we do that? There's got to be a game that has.
Poker.
Yahtzee.
Poker was with cards. Yahtzee, you roll 5.
You could do it.
So you could actually do that. The probability, well, could we do that? What is the probability of in one roll rolling a Yahtzee? Well, it would be this. I mean, first of all, the first dice doesn't matter because you're trying to match that first dice. So you don't have to think about getting 4 of the same. Okay, for example, let's say on the first dice you roll, you get 3. Okay, you're going to get that. That's your starting point. Now you've got 4 other dice that have to land on a 3. What's the probability of this one landing on a 3? How many sides to a dice?
6.
How many 3s?
Uno.
So you've got 1/6 chance of that one landing on a 3, 1/6 chance of that one landing on a 3, 1/6 chance of that landing on a 3. And this one you're going to get the 3 to start off with, so it doesn't matter. So 6 times 6 is 36. 36 times 6? What, 216? Yeah, 246. 18, no, 216. And that times 6 is about 1,300. 1 in 1,300 times if you roll just on one roll. Now the thing in Yahtzee is you get 3 rolls, so the odds change. I mean, it's going to be greater because you can get that. But just to do it in one roll, about 1 in 1,300 times will you ever do that. That's a lot of games of Yahtzee because how many times do you actually roll in a game? What do you get, like 12? Okay, let's see. Now, so let's say you've got this. Let's say you've got a spinner with the numbers 1, 2, 3, and 4 in it, and you are flipping a coin. Abraham Lincoln, no hair. Okay. If I asked you what the probability of spinning a 4 and then flipping a head would be, what would be that probability? Spinning a 4 and then flipping a head. And again, it's just a matter of multiplying the probabilities together. What's the probability of spinning a 4 and what's the probability of flipping a head? Samuel Poppins. Let's look and see. Probability of spinning a 4, there's 1 4 out of 4 different spots. Heads, the probability is 1 out of 2. Probability of both of those happening is going to be 1 out of 8. That is correct. What would be the probability of, here's a good one, probability of drawing 2 hearts, well, in a row from a deck of cards? You'll get this wrong, but I'll tell you this.
Wait, how many cards?
52 cards, 4 suits, 13 in each suit.
Wait, what?
Oh, yeah.
52
Oh,
cards,
my God.
4 suits, so that means there's 13 hearts in a deck of cards.
So,
13 out of 15.
Well, let's do it this way. Probability of drawing a heart out of a deck of cards the first time is
1/52.
13 out of 52, which happens to be the same as 1/4. But we can't use that because it's not, if you've already drawn a heart out, that heart is now gone from your deck of cards. So the new there's a new probability for the second one because you don't have the same number of cards left, nor do you have the same number of hearts left. If you've pulled one heart out, How many cards do you have left? 51, and how many of them are hearts? 12. So the probability of doing a heart after a heart is multiplying these two together. 12, well, we could reduce. 4 goes to 12. 3 over 51, but what, 1 in 17. Because 3 over 51 reduces down to 117. 1 out of 17 times, given a deck of cards, would somebody be able to draw 2 hearts in a row? Back to back. How about that? Isn't that exciting? Alright, now
Yes.
let's write down this problem. Jimmy has a bag that contains 2 red, a bag with 2 red, and 3 blues, thank you very much. 3 blue marbles. What's the probability he selects a red marble and puts it back and then selects a blue marble? What's probability of selecting a red marble, putting it back, and then selecting a what? A blue marble. Now, what should I see on your paper, you ask?
Marbles.
Lovely.
A bag.
A bag. And in the bag you have 2 red marbles, and you could just simply just put 2 R's there, I don't care. And you have 3 blue marbles. Okay. And then you should also write down for me, what are we looking for? You should write this down there. I want to know the probability of a red, comma, and then a blue. This is kind of important. It's a nice mathematical way. It's shortened and condensed, so you don't have to write the whole word probability out there. And then what is the probability of drawing a red marble there, Colton? Shoot. It is not 2/3. How many total marbles are there? It's 2 out of 5 to draw the red marble. Because it's how many red out of how many marbles there are. And that's going to get multiplied by what's the probability. Again, notice this time he took it out and put it back, because if he didn't take it back, if he didn't put it back in, then your probabilities all change, because you don't have as many marbles in there, and everything kind of goes differently. What's the probability of getting a blue one? Bailey, Lincoln? 3/5. So the probability of doing both of those back to back, multiplying together, you get 6 out of 25. 6 out of 25. 2 times 3 is 6, 5 times 5 is 25 times. Is there some sort of a question out there? One last question. If 2 number cubes are rolled, how many possible outcomes are there for which the first roll is even and the second roll is even? Let's go back to our little chart. How many outcomes give you both dice being even? In other words, it would be even, 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 even. Are there any other combinations there where they're both even? I don't believe it. So, how many choices are there where they're both even? 9 out of 36, 1/4 of the times, which makes sense. How many times would there be where they're both odd? 1/4 of the time. How many times would there be where you get one even, one odd? Half the time. Look at Sam, her mind's just turning like a steel trap.